All right, guys, here we go. We're second to last section here for the year. So 10.4, looking at page 298 in your journal for this one. So yeah, we are jumping over 10.3, just getting into the last couple sections here. So what we're looking at in this one, we are going to see a couple formulas for this, but we want to talk first about the idea between overlapping events and disjoint events, or you could also call them mutually exclusive. So these type of events, disjoint or mutually exclusive, same thing, is when they have no outcomes in common, right? So like if I was talking about flipping a coin and rolling a die, right? A coin has heads and tails, a die has numbers 1 through 6. They don't have any outcomes in common, right? They're totally separate results, right? And so those are disjoint events. Overlapping events would be when you do have things in common. So if I was talking tossing two dice or two coins, or I'll give you a couple examples right here, but when you're talking about those obviously have some possible common results, right? And so those are now overlapping events. All right, so here's a couple easy examples where you guys can see the difference between overlapping and disjoint. So if I were to toss two six-sided dice, right, and you can keep in mind the like a lattice diagram that we've looked at for the outcomes. So in event A, we're looking at even numbers, and in event B, so two totally separate events here, we're looking at prime numbers, right? And so if you consider the results of two dice that were even, let's just lay those out real quick. So even numbers from two dice, I could get a 2, a 4, a 6, an 8, a 10, or a 12. All right, so those are the results that could be even values that I get from two dice. Are any of those results also a prime number? All right, you guys remember what prime numbers are? Numbers that can only be divided by 1 or themselves. And 2 is considered a prime number. So because there is a result that fits both of these events, right, then these two events do have overlapping results, right? That would be that guy right there. Disjoint is when they have nothing in common. So if you look at these two events, in the first event, it's either a 2 or a 4, but in the second event, it's an odd number. Obviously, these have nothing in common, right? You can't have a 2 or a 4 as well as an odd number. So these are disjoint events, or you could call them mutually exclusive events because they have nothing in common. So jump down to this guy with me. So we're going to identify a couple things, and a little of this is just getting used to some of the notation that you're seeing right here. So this is what we're going to be going through on each one of these. So if we had just one six-sided die that got rolled, right? So it could either be a 1, 2, 3, 4, 5, or 6. So that's our sample space right there, sample space. So in event A, so that's this guy, the probability of event A. What's the probability of getting an even number, right? Well, if you look at 1, 2, 3, 4, 5, or 6, we know that 3 out of those 6 are even numbers. If you look at event B, what's the result of getting a probability of getting a prime number? Your prime numbers, sorry to tell you, but they don't count 1 as a prime number. So I know it seems like it should be, but it doesn't. But it's not. So 2 would be a prime number, 3 would be a prime number, and 5 would be a prime number. So 3 out of the 6 are prime numbers. So this is for event A and event B. So now we're looking at, what about the probability of getting both A and B? So are there any cases where it's an even number and it's a prime number? So as you look at your list right here, this guy is the only one that is both even and prime. So 1 out of the 6 fit that description right there. Right, it's both. It's even and prime. So what about the or scenario? Which ones would I identify as either even or prime? Right, so now it can be either one. If it's even, it counts. If it's prime, it counts. So let's see, even or prime, we would say, yep, he's even. Yep, he's prime. Yep, he's even. So those 5 out of the 6 are even or prime. Right, it just has to fit one of those descriptions to count. So what we're going to see here in a minute is when you look at this formula, right, where do we get this idea, right? We're going to put all 4 of these together within one formula today. And I'll show you that on the next page, but it goes something like this. It says the probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. So the idea is we are doing this plus this minus this in order to get this, right? And the reason we would do that is because if I added those together, I would get 6 out of 6, which doesn't fit that description, right? Why does that happen? Well, with these guys, if you just added this plus this, you would be counting this one twice, right? You would be counting it as an even number in this probability. You would then count it as a prime number in this probability, so you're counting the same value twice. So we have to subtract out that one item that they had in common so that we don't count the same number twice in order to get the proper answer that looks like this. So here's the way that we're going to set those up today. It's going to look like this. So let me jump over to 2 pages further and give you that formula. So this is on page 300. So this is the formula. So the probability of A or B is equal to A plus B minus A and B, right? And so that's our formula today. Now there are cases where this might be 0, right? Maybe they don't have anything in common. And so all we have to do is this, right? Just do A plus B, right? So if they are disjoint events, meaning they don't have anything in common, then you'll notice that part of the formula won't be needed in those cases. So let me go to a couple examples for you. So page 301. So these ones are disjoint, right? Which means they don't have any overlap. They have nothing in common. So all we have to do, like I was showing you in the last formula, is to, in order to get A or B, I can simply add the probability of A plus the probability of B in order to get A or B. All right, and so this is what it would look like. Don't forget you need common denominators and all that fun stuff when you're doing fractions. Let me go to this one. So now this one, these are not disjoint, so these do have some kind of overlap, and really that's what they're asking us to find, is what's the probability of A and B? What do they have in common, right? What's the overlap? And so all I'm doing is plugging into the formula that I just showed you on the last page. So the probability of A or B was 0.6, so I'm plugging into that piece of the formula, the probability of A plus the probability of B minus the probability of A and B. This is like our X. This is our variable, right? So this is what I'm trying to find. So all I had to do was add those two things together, subtract them over to the other side. I then divided everything by -1 in order to get our answer here for A and B. And you can always check it. If I were to take this and plug it back in, you'll notice that it does fit, right? 0.5 plus 0.05 minus 0.25 does equal 0.6. All right, so we know we got that right. So let me give you the kind of the word problems. These are the more important ones that we're going to be doing. So here we go. So a couple things they're telling us. We got 3 red minivans, 2 blue minivans. We got a black pickup truck, 3 black motorcycles, 1 red motorcycle. So we got all this stuff going on. Okay, so let's just go through what's needed for each one. So anytime you see the word or, that has to now stand out to you, and we're going to use our formula. Okay, so what's the probability of a red vehicle or a minivan? So as we just looked, the probability of red or minivan is equal to red plus minivan minus red and minivan. Okay, that's our formula for the day. So all we're doing is plugging numbers into that. So let's figure out what's the probability of getting a red one. So if you look at all these, if you add them all up, they do add up to 15. So as far as the red ones go, I have 3 red minivans and 1 red motorcycle. So 4 out of the 15 fit that description. They're red. So how many minivans are there? Well, right here, if we add those together, we can see that 5 out of the 15 vehicles are minivans. So that's this one. So here's where we have to take something into account. I can't just add those together because otherwise I'd be counting some of the same vehicles twice. So we're going to subtract out the ones that are both red and minivan, which is that description right there. There are 3 red minivans. So we're going to subtract out the red minivans in order to get our answer right there. All right, so here's a great one if you want to try one on your own, to pause and give it a shot. So scooter or a black vehicle. So again, if it's either scooter or black, as soon as you see the word or, you got to use today's formula. So the probability of getting a scooter or probability of a black vehicle minus the probability of a scooter and black vehicle, right? So a black scooter, basically, as you look at this. So in this case, there were 2 out of those 15 were scooters, 4 out of the 15 are black. There were no black scooters in the mix, so that was 0. Remember, that means these are disjoint events, and so I can simply add those together in order to get our answer. Okay, last couple. Bear with me. I'm trying to give you as much as I can here. So 2 more. So during a basketball game, coach needs to pick a player to make a free throw. There's a 68% chance that he will select you, a 26% chance that he will select your friend. What's the probability that he will select you or your friend? So again, when I see the word or, I know I need to use today's formula, which is to do this plus this minus anything that they have in common. So if we were to kind of put that into a formula, we would say, what's the probability that he gets you, plus what's the probability that he gets your friend, minus what's the probability that he gets you and your friend, right? Well, in this one, it said there's a 68% chance that he picks you, or plus there's a 26% chance that he picks your friend, minus what's the probability that he picks you and your friend, right? It'd be 0, because he can only pick one player. So if he can only pick a player to make a free throw, then there is a 0% chance that he gets you and your friend. So these are disjoint events. All we have to do is add these together, and we got our answer. And then last one. So these ones are not disjoint. Again, you have the word or, so we're going to set up the formula. So homecoming or prom. So we're looking at homecoming or prom is equal to homecoming plus prom minus both. So there's 40 parents chaperoning the homecoming dance. There are 65 parents chaperoning prom. So that gives us this guy right here. So 40 out of the 120 are doing homecoming. 65 out of the 120 are doing prom. Minus how many are doing both, right? And then that's what they're asking us. So how many are doing homecoming and prom? Well, it says up here that 90 out of the 120 are going to do one or the other. They're either going to do homecoming or prom, right? So 90 out of the 120 are going to do homecoming or prom. So if we just insert all this information into our formula, then we're going to solve for the one missing piece, right? So if I add those together and subtract them over to the other side, and then I would divide everything by -1, and that gives us our x. So that is it for 10.4.